So this is the antenna array that I have set up on my car. The wires just go in to the car down there. It's a circular array, spaced at about 23 centimeters. Okay, now I'm in my car, and I've got my Raspberry Pi 3 there, the KerberosSDR, and a good battery pack that's able to put out 3 amps on 2 output ports. So I'm going to connect them all together, connecting the KerberosSDR to the battery first. Like so. So that's connected, and now I'll connect the Pi to the other 3 amp output port. There we go, now it's starting up. Now I've just connected my smartphone to the Kerberos Pi Wi-Fi point. So what I've done now is I've just browsed to the KerberosSDR web interface address, and now I'm going to input the frequency and set the gains and sample rates. So today I want to find the location of a tetra transmitter, which I found using SDR sharp and a regular RTL-SDR to be at 858.8125 megahertz. I'll leave the sampling frequency at 1 megahertz, and I'll set the gains to about 33 dBs on all of them together. Press update receive parameters, and that should be updated now. Now I can go ahead here and click on start processing, and we should now see that an update rate is showing here, which is correct. Now I'll go to the sync tab up here. I'll turn on the noise source, and I will enable the sync display. Click on update, and in a few seconds you should see the graphs. Here they are. So you can see that it's out of sync right now. So what I'm going to do is I'm going to click on sample sync, and then once that is synced, go to calibrate IQ. So now all the graphs are at 0, which means that the KerberosSDR is in sample and phase sync. So now I'll just go and turn off the noise source and the sync display, and press update again. So that stops the graphs from updating and taking up our CPU power. Now I'll go back to the configuration and spectrum screen, and what I want to do is set my filter bandwidth to approximately the bandwidth of the signal that I'm looking for, which is about 30 kilohertz. I'll set the FIR tap size to 100 so that the entire bandwidth is not used. And I'll set the decimation to 4, which will improve our CPU usage, and I'll click on update IQ parameters. And there we go. It's set. Now what I need to do is connect the antennas to the KerberosSDR. So just a little tip, you can see in the switches there, they're all on, and they're labeled 1, 2, 3, 4. So this is port 1, port 2, port 3, port 4. Okay, so now I've got everything nicely tacked down so it doesn't move around while driving, and I'm ready to go into the direction DOA estimation tab of the web interface, and I'm going to set the arrangement to UCA because I'm using a circular array, and if it will focus, I'll set the spacing to 0.33 because that's the spacing I've chosen for my antenna array. Now I'll click on enable DOA, and I'm going to be using the music algorithm because that seems to be the best for most cases. And finally I'll click on update DOA, and here we go. We have the graphs ready. and updating at about 760 milliseconds per update. Okay, so I'm now in the KerberosSDR app. What I'll do is go over here and I'll go to settings, and I'm going to change the server address to the address of the Pi server, which is 192.168.4.1:8081. Press OK. I'll leave the update interval at 1 second. I want logging to be on. I want logging to stop when I'm stationary. I'm going to set the log file name to 30.04.19 _ 858.csv. Okay. I'll leave the plotting step at 1 for the meantime, and the plotting length at 10 kilometers. I want to set the minimum required confidences to 0 for now. And I'm using bearing mode of GPS. Reverse antennas off, because I have them the right way around. And I'm using an array type of circular. And we don't need to worry about the last one, because that's only for linear arrays. So now back in the main screen of the app. And of course, if you haven't downloaded the maps offline yet, you should do that before you connect to the KerberosSDR Wi-Fi by using this button here, the download button, so you can have some offline maps when you're driving around. But now I'm ready to start direction finding, so all I need to do is press this button here, and the updating has begun. So I'm going to put this on my window shield now and set up the camera so that you can see what happens when I drive around. So now what I want to see is the log file that we've just made by driving around a bit. So what I'm going to do is go to here, go to the little setting up there, go to open log, and I'll find my log file that I created today, which was on the 30th. And then I'll go here and click on show hide log. So that shows me the log that we just made. So you can look around the map, see where the lines are pointing. So judging by the lines, the transmitter must be probably around here somewhere. This is where the majority of the lines are going. So these other ones are just from multipath, but the majority of lines seem to be going this way. So what I'm going to do is I'm going to plot a path that takes me around here, around this area here, so I can try and find more angles to try and locate the transmitter and get more heat map data as well. See, these colors here are showing how strong the signal strength was. So hopefully if I drive down here, I'll start to get more red spots wherever the transmitter is located. In my office, and I've just collected all the log file data that I need. So now I'm going to go and open that log file and see what we've got. This is a note. I've set the plotting step here to 5 so that not all the points are plotted, only every 5th point is plotted. It's because we have a lot of data, because I was driving around for just under an hour. So if we're collecting points at every 1 second, then that's a lot of data to plot for an Android device. So we need to thin that data down a bit. Click on show hide log. Alright, so there's a lot of data points there. And so judging from the heat map data, it seems that the hottest points are around here. And if we zoom in there, You can see that a lot of lines are crossing at around this point here. Right about here. So what we think is the transmitter is probably around here somewhere. Now what I actually did was I went online and I looked up the location of the transmitter on our local database, and I've added it to the towers here. So actually you can see that it's right there, so the direction finding results were correct. Now if I wanted to try and get rid of some of these multipath lines, I could go back into the settings and I'd set the required power to plot to say maybe 10. So that will reduce any, remove any points that have too low power detected, because they probably won't give a good result. And I can also put the confidence up to maybe 15. Let's go back, and I can see the points have thinned down considerably. And we're still seeing that the majority cross by the transmitter. Could actually reduce the plotting step back down to 1 now. And see what we get. It does take a while to plot with this many points though. Here we go. So yeah, you can definitely see that the majority are crossing by the transmitter. So that's given us a pretty accurate result. So in this one I've reduced the plotting length down to 1 kilometer only, so we're only looking at results from when we drove nearby the transmitter. So it does look like it still crosses quite nicely.